This video was brought to you by the ILC. Hello there once again. Welcome to episode 57. In this episode, I'm going to show you how to solve an equation involving Newton's law of cooling using logarithms and exponentials. Let's have a look. Our problem says a cup of hot coffee at 170 degrees is left in a room that is 70 degrees. If the cooling constant of the coffee is K equals 0.1 per minute, how long will it take for the coffee to reach 100 degrees? I've started us off by writing Newton's law of cooling underneath, and I want to go through what each letter means, because right now it looks like just a random jumble of letters. Let's start with Y. Y represents the current temperature. Alright, now we are trying to find how long it takes for the coffee to reach 100 degrees. We'll let that be the current temperature. Capital R represents the room temperature. The problem says that the cup of hot coffee was left in a room that's 70 degrees. We'll write that here, and we'll show this other R is also 70. The capital A is the starting temperature for the coffee. The problem says the cup of hot coffee began at 170. We'll write that here. Now on to E, raised to the negative kT. The K value is the cooling constant. This number represents how fast certain things cool off, with higher numbers meaning they cool off quickly. Our coffee has a K equal to 0.1 per minute. Now the T represents how much time has passed. And our question asked us, how long does this take? So that means the time that's passed is unknown. We'll box it in. Alright, now that we know what all the letters mean, let's start replacing them. We'll have 100 equals 70 plus 170 minus 70 times e to the negative 0.1 t. As usual, our unknown is in the exponent. And when the unknown is in the exponent, we need to get the exponential by itself. Alright, so we need to move all the other numbers away from the exponential. Let's start with the one that's furthest away, the 70. It's not multiplied by the exponential, so it is easy to move. Subtract 70 from both sides, and you'll have 100 minus 70 is 30. Let's also simplify this part here. 170 minus 70 is 100 times e raised to the negative 0.1 t. Now, because we have a number times the exponential, let's take it away by dividing. This cancels out the 100, and 30 divided by 100 is 0.3 equals e to the negative 0.1 t. Now, what we need to do is clear the exponential. And to clear an exponential, we are going to have to use some kind of logarithm. So to solve this, we need to use log base e, which is the same thing as ln, or natural log. So let's take natural log on both sides. We'll have ln of 0.3 equals ln of e to the negative 0.1 t. But ln and e are inverses, so that you can cancel them both out. So our equation is now ln of 0.3 equals negative 0.1 times t. Now all we have to do is divide both sides by the negative 0.1. So our answer will be t equals ln of 0.3 divided by negative 0.1. If we do the math in a calculator, our t will be equal to 12.04. Now, remember that our cooling constant was per minute, so our time will be 12.04 minutes. And there you have it. That's your answer. This marks the end of our regular Math 171 video series. If you've stuck with me through all 57 episodes, thank you very much for watching. I hope you learned something and I hope you enjoyed it. With any luck, we'll see you again next semester.